All right, so we've taken in a lot of information, but really we need to organize the information we have, and really I think that you guys can fill out this flowchart by yourselves already, and you should take a minute to try and do that. Take however many minutes it takes, but essentially we have nucleophile base type, two different things. So you'd put something in those boxes. This box leads to unimolecular only. This box leads to bimolecular only. Then we have different things you need to fill in there for E2, SN2, or a mixture. This box would lead to SN1, E1. This box would lead to no reaction. This box would lead to SN1, E1. So take a minute to do that. You have to make these ideas work in your own brain so you can understand them. So take a minute to do that. So you pause the video where you already did that. That's great. So nucleophiles and bases can be classified as either, if they're doing bimolecular only, they're not waiting around. That would mean that they were strong. Whereas unimolecular only is weak nucleophiles and bases. If we go to that bimolecular, if we're doing exclusively E2, that would be a tertiary alkyl halide that did that. Well, exclusively SN2, that would mean it's really easy to access that antibinding orbital. We would have primary alkyl halides only. And if it's a mixture of the two, we would have secondary alkyl halides only. What's this asterisk for that I put down there? Well, how can we take these and force E2 instead? Well, if we have a big, bulky, strong base, and remember that was that tert butoxide, that can also force E2. So this primary alkyl halide will do SN2 unless we have a really big bulky base. This secondary alkyl halide will do a mixture unless we have that big bulky base that forces E2. What about over here? Unimolecular reactions only. If we have no reaction, that means that the carbocation couldn't form. That's going to be the case with a primary alkyl halide. What did you guys put in these boxes? It really doesn't matter. You could have put tertiary there or secondary there. Both of them are going to lead to that mixture. So I'll put secondary alkyl halide here, tertiary alkyl halide here. Once that, there we go, you can see the secondary alkyl halide now. Once that carbocation forms, it's going to always do a mixture. So that's the situation. So you shouldn't be memorizing this. You should be understanding why each of them do what they do. So I like organizing it for you, but I also want you to take that time and effort to understand why each of these things works the way they do, because then you won't have to memorize the chart. You'll just understand, oh, this is what we look at first, then we look at this, and now this reaction is what makes the most sense. So hopefully you'll get there.